Find me the page.
You're always recording in our phone.
I record in every block.
Oh, actually?
Yeah. I record in every block, unless I forget to hit record. That happens sometimes. But I record every lesson in every block.
Just really like our phone.
No.
Oh, you don't like our phone?
Well, I do, but that's not why. So, if x equals 2y, what does y equal? So, all the stuff that, no, 16, no. All the stuff that we've been doing here, isolating for a variable, we can do when there are more than one variable. So right now, this equation is isolated for x. X is by itself. I've got x equals 2y. If instead I wanted to get y by itself, what would I have to do to both sides? Divide by 2. Okay, so let's do that. We're going to divide by 2. We're going to divide by 2. On the right-hand side, those 2's cancel. Leaving us with just y on the right-hand side. On the left, we've got x over 2. And that's it. We're done. We've isolated this thing for y. We found out what y equals. Y is half of whatever x is. So if x is 4, y would be 2, which works the other way here too. If we go back to the original question, we said x is equal to 2 times y. X is twice whatever y is. So if I have 4 and 2 again, if y is 2, 2 times 2 is 4, and it works both ways. The first one's isolated for x, the second's isolated for y. They both contain x's and y's, but the thing that is alone in each case is different. So we're just going to do more of this stuff. We're just going to make it more interesting. Let's take a look at this guy. Zoom in on question 1. So I've got an expression here. X plus 4 divided by y equals 3. And what we're going to do is we're going to do this question twice. Once where we isolate for x, and the other time when we isolate for y. It doesn't matter which one we do first. So I'll leave it to you. Which one do you want me to isolate for first? X or y? X? Okay. So we're going to solve this thing for x. X is up there in the numerator. So all the skills that we've looked at before are just going to be, like, none of that has changed. The steps don't change. So the first step that I gave you for something like this, when the variable is up there in the numerator, was to do what? Sorry? Say it again, Brielle. Was it not you who said something? Oh. Juno said something? Yeah, we're going to throw brackets around the numerator because I've got a binomial up there. And now we don't like fractions, so let's get rid of them. How do I get rid of divided by y? Yeah. We're going to multiply by y. And whenever we do to one side, we have to do to the other side. Ruben, this is what you were asking me about at lunch. When I've got this numerator in brackets, the y multiplied outside and divided by y, multiplying and dividing by y cancel, leaving me just with x plus 4. Because I've put brackets around this thing's treated like one object multiplied by y. You don't multiply both of these by y. Just, you put brackets around it and multiply the entire binomial by it, and then it cancels. There's nothing to distribute. You follow what I'm saying? Okay, that's what you're asking me about at lunch. So on the right-hand side, now we've got 3 times y. That's just going to be what? It's going to be 3y. Now, well, what are you guys thinking for? Krishan, you said you wanted to isolate for x. So let's get x by itself. What is x attached to? The 4. How? It's being added to the 4. It's x plus 4. So how do I undo that to get x alone? We're going to subtract 4. We're going to subtract 4. On the left-hand side, the positive 4 and the negative 4 cancel, leaving us just with x. On the right-hand side, we have 3y minus 4. So do I have an expression where x is alone? No idea who's using the printer. Either Mr. Federley, Mr. DeVries, Miss Craig, or Mr. Keeley.
I mean, there's only 3 classes. Bet on it.
Bet on it?
Acknowledge.
So, answer my question first. Have we isolated x? Is it alone? Yeah, so we're done. Your answer is no longer, oh, it was Mr. Keeley. I would have been wrong.
That's what I said.
I thought it was Miss Craig. We were wagering on who it was. I was wrong. Hey, don't you dare. Not kind. Keep those kind of comments to yourself. Mr. Keeley is not an idiot. Mr. Peter Griffin is an idiot. Okay, so let's go back to the same question, except we're going to isolate for y instead. I'm going to grab another color. Boom. Let's write out the question again. We've got x plus 4 all over y equals 3. Now the thing we're trying to isolate is buried there in the denominator. We dealt with those on day like 1 or 2 of this chapter. If the variable is, it could have day, you're right, it could have been day 3. If the thing we're trying to isolate for is down there in the denominator, what do? We multiply by it. Get it up out of the denominator. So I'm going to put brackets around my numerator and I'm going to multiply by y. Interesting how that's the same first step. On the left-hand side, the y's cancel. I get x plus 4 equals 3y. Now this time we want to isolate for y. So this is where the step is different. What do I have to do? What do you mean nothing? No, it's not. I have a 3 times y. Yeah, so we're going to divide by 3. And whenever I do to one side, I have to do the entire other side. So on the right-hand side, my 3y divided by 3 is just y. And on the left, I get x plus 4 all over 3, and we're done. It doesn't become this nice, tidy little number because there's variables in there. But we've isolated for y successfully. Y is alone. It's not bad. No, well, you could tell that by the color on the outside. It's green. Okay, let's do another one. We're just full of profound ideas today. No, the banana was not ripe. Hayden and Marcus, keep your hands to yourself. Well, I saw you react to Hayden, so I wasn't sure if you started it. Here we go. Next question. I've got a 2a plus 4, and in the denominator I have x minus 1, and that whole thing is equal to 5. I want to isolate this thing for a and x. It doesn't matter which one we do first. So not Gershon. Someone else decide now. Which one do we want to start with, a or x? A. Okay. Dilkron says A. Here we go. So A is buried there up there in the numerator. So what are we going to start with? What are we going to do first? We're going to throw brackets around the numerator, and we haven't seen one of these before. I have a binomial in the denominator for the first time ever. So in addition to putting brackets around the numerator, because I have multiple terms down there, we're going to throw brackets around that guy too. We're going to take a skill we've done before and we're just going to extend it. I put brackets around a binomial in the numerator, so I'm going to put brackets around the binomial in the denominator. Now, I want to get a by itself, so we're going to get rid of the denominators first. So what am I going to have to do? Yeah, I got to multiply by this whole denominator, the x minus 1. So we're going to throw down a set of brackets up here, x minus 1, and we're multiplying by that. And on the right-hand side, we do the same thing. Multiplied by brackets x minus 1. On the left-hand side, the multiplying by x minus 1 and the dividing by x minus 1 cancels. And on the left, we're left with 2a plus 4 equals. Now, there will be those of you sitting out there who will say, we could divide here by 5. While that is true, to keep things consistent, and in my experience, to prevent the greatest amount of mistakes, actually, we don't want to divide by 5 because we're not isolating for x. What I want you to do here is actually do this multiplication. How do I multiply 5 by this binomial? Gershon, distribute. You have to multiply that 5 into both parts. So we're going to get 5x minus 5. Okay, now we're isolating for a. So now, yes, still Karan, what do I do? Answer my question. Yeah? No. These are on opposite sides of the equal sign. So we can't group over top of the equal sign. No, there are no like terms. What am I doing, Charlie? You're so close. Subtract 4. That's not what you said. You said the plus 2 and the minus 5. You only said the plus 4 and the minus 5. No, we want to take away the 4. No, you said plus 4. You did. We want to subtract 4 on both sides. On the left, we're left with 2a equals, and now I've got 5x minus what? I have negative 5 minus 4 is? Negative 9. It's going to be 5x minus 9. Now I want to get the a by itself, so what are we going to do? Divide by 2. And on the right-hand side, we have to divide the whole thing by 2. So we're going to get a equals 5x minus 9 all over 2. So we've got, I mean, it's not a very nice expression, but at the end of the day, I mean, it's not like 5 or negative 1. Like, it's not a nice, this is the value for that variable. It's not compact. It's not a singular number. But we've isolated for a using the skills that we've developed over the last week or two. We're done. Yes, still Karan. That's the next question's problem. We're not there yet. Okay, we've isolated this one for a. Let's go back and do it for x. Write out the question again. 2a plus 4 over x minus 1 equals 5. Now this time we're going to go back through and we're going to isolate this thing for x. X is trapped in the denominator. So to get it out of the denominator, what do we got to do? We are not multiplying by x. We're going to throw, just like before, we throw brackets around the numerator. Because we have a binomial in the denominator, we're going to throw brackets around the denominator. And we're going to multiply both sides by the entire denominator. Yes, Raven, was that a question? No. Okay. So on the left, the x minus 1 and divided by x minus 1 is going to cancel, leaving me with 2a plus 4. And because that's the only thing there, we can drop the brackets again. Equals. Mr. Keeley. Now, this is where some of you might say, oh, we can divide this thing by 5. We could, but it's going to make the expression really ugly to deal with. What I still want you to do here is to distribute that 5 in.
Got it.
Well, it was him last time, so it's probably going to be him again. He's just wishing you a good day. He said, I hope you have a good day, Mr. Keeley. Okay, we've distributed this thing in here. How do I, well, and the rest of this is going to follow very similarly. How do I get x by itself? I want to get rid of things that are furthest away. Plus 5. No division until it's the only term left. So we're going to add 5 to both sides. We're going to get 2a, what? Plus 9 equals 5x. That is my question. Divide by 5. And when you do that, the whole left-hand side needs to be divided by 5. So we've got 2a plus 9 all over 5 equals x. Is x alone? Then we're done. Don't worry about pi. Pi is 30 seconds from now's problem. Questions about what we've done here? Okay, yes. You mean isolating for x is easier than isolating for a? I mean, it's the same set of steps. You're just adding and subtracting by different, or adding and subtracting and dividing by different things. Okay. Here we go. What is that expression? Hands up if you recognize that. Gershon, what is it? No, the expression, the whole thing. I didn't ask you for that one random Greek letter. I said, what is this? Which is equal to what? Area of what, Marcus? This is the area. This is the expression for the area of a circle. You would have learned that back in middle school at some point. The area of a circle is equal to pi r squared. R is equal to what? R is the radius. So by isolating this thing for r, wow, you guys are chatty today. By isolating this thing for r, what are we finding? We're finding what is the radius given a particular area. This is, again, the steps that we're going to go through are similar to everything we've done before. The only extra added piece here is now we've got an exponent on the r. So I want to draw your attention back to how I explained what we were doing here on like day 1. I explained it 2 different ways. One of the explanations I gave you was we're going to isolate by doing opposite operations. And I said that you can think of opposite operations as not bed mass, but the other way. Sam Deb. Okay, which is just bed mass but backwards. And this is the order that we're going to use to isolate the stuff that we've got. Brielle and Raven start talking to each other. You were talking, you know what you were doing. I said what you were doing. No, you weren't. Stop talking. Not another word. That was another word. See you later. Yeah. I'm chewing out Raven. And now you're making a smart-ass comment about my parenting. I was asking Raven to stop talking. Because every response to everything that... I might. Okay. My children, Del Quran, are 4 and 2. No, I do not talk to my children this way. I asked Raven nicely over several weeks to stop doing the things that he is doing. Raven has pushed me to this point. Would I speak to my children this way at 14 if this same behavior had been going on for literally months? Yes, I would. You don't need to get involved, Hayden. You don't need to just for the love. All of this is being recorded. It's going to get uploaded to YouTube in a little bit. It's all going. Nope, it's all going on YouTube. Your parents wonder how things go in class? I can send them this link. Here we go. I could even turn this around and be like, look, there's the people. Okay. It's just you. It's true. Okay. At the very beginning of this chapter, I tried to have you guys think about what we were doing as backwards bed mass. So we have no subtraction or addition here. Boom, boom. There's nothing to do. There's nothing to get rid of here. We are multiplying by something. This is the Greek letter that lots of you recognized as pi. You're saying, well, let's make it 3.14. Let's not make it 3.14. 3.14 is some rounded mess. Why not make it 3.14159? Why not make it 3.1415926 or whatever it is? I had a buddy who could recite this to 50 decimal places. Is that what we want to write down? No. This nice, beautiful little symbol will be dealt with on its own. Right now we have pi times r squared. Exponents are going to get dealt with later on over here. We're going to undo the multiplication by pi. What is the opposite of multiplying something by pi? Dividing by pi. So we're going to divide by pi, divide by pi. On the right-hand side, the pi's are going to cancel. And we're going to be left with r squared on the right-hand side equals a over pi. There's nothing to simplify there. Those are 2 letters. How am I supposed to do math with a bunch of letters? Well, we are. Here we go. English, it's right. Multiplication and division are done. Now I want to isolate this thing for r. I want to get r by itself. Currently it's not. It's currently r squared. So way back in the exponents chapter, chapter 2, we looked at squaring things and the opposite of squaring things. What is the opposite of squaring something? Juno? Square rooting something. And so because squaring and square rooting are opposites of each other, to get r by itself here, we are going to, and I said in that chapter that roots and exponents both fit into this E section, we are going to undo the square by square rooting. And we're going to do that to the whole right-hand side and the entire left-hand side.
What?
Just like that, just like that. I mean, the bigger issue is here we've got an A there. So I'll give you an example. Okay, I'll answer that. Gershon, give me 2 seconds, 30 seconds, and I'll answer that question. So on the right-hand side here now, because squaring something and square rooting are exact opposites of each other, those 2 operations cancel. They undo each other. So on the right-hand side, all we're left with is r, and this becomes the square root of a over pi. Now, Gershon asked the question, and Marcus did too. How do you shove that thing into your calculator? Well, given what we have here, an a, there's nothing to plug into your calculator. There are no values here. Pi is a number. Your calculators have pi buttons. So then, this is the kind of question that this would answer. Given a circle of a particular area, Gershon, pick a number between 10 and 50. 32. Okay, so let's assume that we have a circle and we know the area is 32 centimeters squared. I want to find the area of that. For some reason, that's the question that's being asked. So to use a calculator for that, it's the same thing, similar to what we've done before. We're going to open up on this, I'll use, this calculator. It's a square root button. So this is the Casio. This is the square root of, well, the square root of what? On the inside, we've got, you told me that you wanted the circle to have an area of 32. So 32 divided by pi. That's what a fraction is. Fraction is just division. So inside this root, I'm going to go 32 divided by, and now this thing has a pi button. On this calculator, it's down here. It's a yellow letter, so that means I have to hit the shift button to get it. So shift, there it is. The radius of that circle is 3.2 centimeters. That's how you shove that into a calculator. It would do that kind of thing. Yes, sir. You probably did the square root of 32 divided by pi. What kind of calculator do you have? This Casio? Does the line go over top of everything? Okay, then here's what you did. You probably did the square root of 32. Your Casio kicked you out of the root and you divided the thing by pi. Notice how the root does not continue over top of the divide by pi. That's what you got, right? So BEDMAS says, your calculator will do BEDMAS. Brackets, there are none. Exponents. Back when I introduced to you roots and exponents are equivalent. So it's square root of the 32, then it divided the thing by pi. That's not what we wanted to do. We wanted to make sure that this thing gets, the whole thing needs to be inside the root. A way that you deal with that on the Texas calculators would be like doing it this way. We're going to square root. It opens a bracket for us. We're going to push 32. We're going to divide that thing by, where's the pi button on this mess? It has its own button right there. We're going to close the brackets, and we're going to get the same value that Casio gave us, 33.2. But on the Texas, on the TI, you've got to use the brackets to make sure that it takes the root of the entire thing. So that's where something like this would get used. Now, my laziest students would say, well, why can't I just get a ruler? You toss me a circle, let me go get a ruler. I'll tell you what the, sure. That would be easier than figuring out what the area is. But, you know, math's never about that, is it? We give you ridiculous examples to get you to use ridiculous expressions when grabbing a ruler and just measuring a thing would often be easier. That's not ultimately the point. Ultimate point here is I want you guys to practice isolating expressions, and this expression here is one that you've seen before. You recognize that. Okay, it's 12:15. There's 45 minutes left in the block. This is all we're doing today. Flip the page. I have 15 questions for you. I need to make a couple tweaks. Here's so question 1. I want you to zoom in on. Actually, you know what? No, everything's good until you get to question number 11. So I want you to take a look at question number 11 here with me. There is a problem. If you flip over, there's an answer key. There's a problem with some of the answer key. And I'll show you what the problem is. If you look how question 6 is written, question 6 says A equals LW. That's an expression you're familiar with. This is the expression for the area of a rectangle. Area of a rectangle is length times width. We want to solve, and then it says comma, solve for L. So it gives you an equation, and then it gives you instructions. Question 11, 12, 13, 14, and 15, the way it's written makes it look like this comma is actually an exponent. It's not. This is not some sort of hidden secret math symbol. It's literally just a comma. This is the thing that you're solving for A. This is the question. This is the instruction. So this whole column, 11 through 15, is exactly the same. If you flip over, one of the answers on the answer key, I think it's actually question 15, when we went through and we did it, the person who made this answer key didn't recognize that that was a comma. They made it a squared, and so that this, yeah, is wrong.
I thought you made that.
I did not make this one. So we're gonna scribble some of these things out here. I'm gonna put the answers that I want you to use for 11 through 15 on the board. If you take a look at the answers for them, 11 through 15 on the back, they use a slightly different technique to get, it's an equivalent answer. It'll be different to what you get because I want you to use a particular technique. Namely, I actually want you to do the distribution. But for those of you who get really comfortable with this really quickly, there are some shortcuts you can take. I don't want to teach the shortcuts until you guys are comfortable with the more thorough, slightly more work way. But if you want the shortcuts, I can show them to you. So this is what I want you to do. I'll put answers to these 5 questions up on the board. This is your homework for today on your Market Site Giver.